Hello everybody, welcome to this video. In this video, we are going to discuss about the kinetic theory. It is in class 11, physics chapter 13. And in the last class, we have discussed about the thermodynamics. You know very well what is mean by thermodynamics. So thermodynamics is a branch of physics that deals with the concepts of heat and temperature and the relation to energy and work. And we can also consider this thermodynamic as a macroscopic science, which deals with the bulk system and tells us about the system as a whole. And in this chapter, we are going to discuss about the kinetic theory. What is called kinetic theory? The kinetic theory explains the behavior of gases. It is explaining the behavior of gases based on the idea that the gases consist of rapidly moving atoms or molecules. So in every particles are moving randomly with a great speed. In solids, the molecules are very tightly packed, as intermolecular space is not present in the solid. So there is no gap between the atoms and molecules. So it is tightly packed. And in the liquids, intermolecular space, the space between the two molecules, are more as compared to solids. And in gases, the molecules are very loosely packed, as intermolecular force or intermolecular space are very large. That is, intermolecular space are very large in gases. The random movement of molecules in a gas is explained by kinetic theory of gases. The rapid movement of the gas molecules are explained by kinetic theory of gases. And we will also see that why kinetic theory is accepted as a success theory. And kinetic theory explains the following things. First one is the molecular interpretation of a pressure and temperature can be explained. And in the second one, it consistent with the gas and gas laws and Avogadro's hypothesis correctly explains specific heat capacities of many gases. In the last session, we have discussed about the specific heat capacity. So this specific heat capacity may vary from materials to material. And see the first one. Here I have given some pictures. In this picture, we can see the arrangement of the molecules. So the molecular nature of matter is going to be explained with the help of this diagram. So in solid, it is tightly packed. It has the definite shape. And in the liquid, the space between the molecules are a little bit moderate. And in the gases, there is a large space between the two molecules. Here, John Dalton atomic hypothesis was given by many scientists, and according to which everything is in this universe is made up of atoms. So each and every particle, solid, liquid, gas, everything in the world is made up of atoms and molecules. The atoms are little particles that move around in a perpetual order, attracting each other when they are little distance apart. So in each and every atoms and molecules, they have the attractive nature. But if they are forced very close to each other, then they repel. So when it is forced to come together, it will try to repel each other. For example, if you consider a block of gold, it consists of molecules which are constantly moving. And Dalton's atomic theory, also referred as the molecular theory of matter. in the other name of Dalton's atomic theory, that is molecular theory of matter. So this theory proves that matter is made up of molecules, which in turn are made up of atoms. According to the Gay-Lussac's law, when gases combine chemically to yield another gas, their volumes are in ratios of small integers. And we are going to talk about the Avogadro's law. So the Avogadro's law states that the equal volumes of all gases at equal temperature. Here the temperature is going to be top. So this law states that the equal volumes of all gases at equal temperature and pressure have the same number of molecules. So for the conclusion, all these laws proved the molecular nature of gases. All these laws prove the molecular nature of gases. Dalton's molecular theory forms the basis of kinetic theory. Why was Dalton's theory a success? Here he has explained matter is made up of molecules, which in turn are made up of atoms. Atomic structure can be viewed by an electron microscope. So with the help of electron microscope, we can view the structure of the atom. And here I have given some of the structure, and the basic differences are given in terms of the molecular structure. So basis of difference, solid, liquid, and gases are given. The first one is about the interatomic distance, that is the distance between the two molecules. In solids, the molecules are very tightly packed, as we discussed before. The interatomic distance is minimum. Interatomic distance is minimum. So the space between the two atoms or molecules is minimum. And then in liquids, the molecules are not so tightly packed. Interatomic distance is more as compared to solid. Little bit gap. And for gases, the molecules are loosely packed, free to move. Interatomic distance is maximum. And the next one, a mean free path, is the average distance a molecule can travel without colliding. So no mean free path in solids, less mean free path in liquids, and there is a free path followed by the molecules that is there in the gases. And we will look at the next topic in the next session. Thank you.